To sum up, ladies and gentlemen, the EU's climate agenda goes beyond environmental protection. It is and should be a powerful lever for boosting competitiveness, driving innovation and investment, and ensuring that Europe thrives in the global green economy. Thank you very much.
Thank you to Kurt for these important insights. And up next we have Tom Mayeran, who will speak about his innovative initiative called Refrosting the North Pole. And let me tell you that I've spoken earlier to Tom and I tried to catch some information from him, and it's really amazing what he's about to present. So Tom is a renowned advocate for climate restoration and will share groundbreaking approaches to reversing Arctic ice melt. Please welcome Tom Mayeran.
For some reasons my slides don't show up. Oh, they do. Okay, wait a minute. Good afternoon. The picture behind me I took when I was at Svalbard in Longyearbyen, which is the most northern permanently inhabited town in the world. And as such, it's home to the most northern almost anything in the world, like the most northern supermarket in the world, the most northern university center in the world, and to my surprise and delight, even home to the most northern brewery in the world. So despite the wind chill factor sometimes as low as minus 50 degrees Celsius, it wasn't that bad to be there. I was there in the dark season, which means it's 24 hours, 7 days a week, it's dark. You literally don't see anything, which is quite boring. But at a certain moment, the moon appeared in the sky and illuminated this beautiful landscape behind me. And when I look at it, it looks almost surreal, like it has been made by artificial intelligence. But sometimes, fortunately, nature can be even more beautiful than we or any AI assistant can think of. Now, you probably expect me today to tell to you how I came to a brilliant idea to try to save this fairy tale-like environment. How creativity has been at the basis of my whole career in innovation. So I thought before this talk, let's fact check myself on my own creativity. And I noticed that I already worked for 26 years within innovation. That goes all the way back to introducing internet services on mobile devices, at a time that we were already happy that we could play the game Snake on our Nokia 3310s. So some of you might remember. And during the time, I helped to introduce 37 different products and services. So that's quite a lot if you look back at it. But then I looked a little bit better and I thought, okay, how many of those products and services were actually based upon my own ideas? Then it gets a bit embarrassing. 0 of them. And this was also the case with what I'm doing right now. I met up with an old colleague of mine, former IGMA, and during a cup of coffee he presented to me an idea that to me sounded like almost impossible to achieve. But if we would be able to achieve it, then the impact would be so huge that they thought it would almost be criminal not to try to achieve it. So within that 1 hour that I had a coffee, I heard myself saying, okay, we have to do this full time for the next years and really try to make this happen. Now, the idea that he presented to me and that I'm going to present to you today is about this. As you all know, the Earth is warming at an unprecedented rate. But what less people know is that the temperatures in the Arctic region, they rise 3 to 4 times as fast as in the rest of the world. And that causes the Arctic ice sheet to melt. And where there used to be 7 million square kilometers of ice in summer back in the 80s, that's now down to 4 million square kilometers. So that means it almost halved during my own lifetime. And if we look at the volume of the sea ice, it's even worse. Then we can state that 2/3 of the sea ice has already disappeared, which means that the remaining sea ice consists increasingly of thinner first-year-old ice and less of the thicker multi-year-old ice. But then the most worrying thing is that the IPCC, even in their most optimistic scenario, predicts a first virtually ice-free summer in the Arctic Ocean as soon as the 30s or 40s this century. And that would mean, for the first time in more than 100,000 years, there will be no ice. And of course you can think, yeah, why does it matter? It's far away. Should I really care? But it does matter. And it matters because of this. The Arctic sea ice functions as the refrigerator of the world. Through its natural white surface, it reflects most of the incoming solar energy back into Earth. And as the sea ice continues to decline, it will no longer be able to reflect the solar energy, which will instead be absorbed by the dark ocean. And where the sea ice is capable of reflecting up to 90% of the solar energy, the dark ocean will reflect will absorb more than 90% of this energy. And that leads to even more global warming. And then the bad thing is, the Arctic is not Las Vegas. What happens in the Arctic doesn't stay in the Arctic. So it's not far away. So besides the accelerated global warming, a set of devastating feedback loops can be triggered, like the release of methane out of the falling permafrost, which is a potent greenhouse gas, as you know, or the weakening of the polar vortex, which is a strong jet stream which contains the cold within the Arctic region, and as it weakens, it will trigger even more extreme weather events. And I think we have had more than enough of these extreme weather events over the last years already. But we're not here to talk about despair. We are here to talk about solutions. And our solution might sound surprisingly simple, and is actually based upon the practice of the Dutch ijsmeesters. So climate change is also affecting the Netherlands. And that means that it becomes increasingly rare that we can skate on natural ice, which is some kind of crazy national hobby that we have. We like to do that. And that's why the Dutch ijsmeesters, the people responsible for ice skating rinks in the Netherlands, they apply small layers of water on top of the ice when the temperatures finally drop below zero to thicken the ice faster. And that way they can open up the ice skating rink only after a couple of nights of moderate freezing. And it was this practice that inspired us to come up with our solution. It's very simple. Pumping seawater on top of the Arctic ice sheet in winter, where the extreme cold Arctic temperatures will make the water freeze rapidly. And this way we will thicken the ice, and the thicker the ice is, the higher the chance that it will survive the warm summer months. Now, of course, we're not in the business of creating an ice skating rink at the North Pole, though that still would be fun. We're going to do it one time maybe. But we want to maintain this function as the Arctic, that the Arctic ice sheet has as the refrigerator of the world. And according to our calculations, depending on the latitude where we will operate, if we manage to thicken an extra 30 to 75 centimeters of ice, then that will extend the lifetime of the ice by 1 month in summer. And if you would thicken 1 square kilometer of ice and make it last 1 month longer, that will have the same cooling impact as the removal of 1 kiloton of carbon dioxide over a 20 years period. Now, of course, our ambition is way larger than just 1 square kilometer. The annual sea ice decline over the last decades was between 80,000 and 100,000 square kilometers. So we made it our ultimate goal to thicken 100,000 square kilometers each year. It sounds like a lot, and it is a lot. But compared to the vastness of the Arctic region, it presents just a small fraction on it. And on the image behind me, you can see the red rectangles showcasing the size of this 100,000 square kilometers compared, I'll get out of the way, compared to both the winter sea ice surface at the left side and the summer sea ice surface at the right side. So then it doesn't look that much, but if you zoom in, it's still twice the size of the Netherlands. But I come from the Netherlands, and as you might know, most of the country lies below sea level, and we already managed to keep dry feet a couple of 100 years ago by pumping the water out of our land using simple windmill technology. So we think in these modern times, with modern technology, twice the size of the Netherlands should really be feasible. Now, where are we on our journey to this audacious goal? the Delft University of Technology already tested the principle of, as we call it, Arctic ice thickening within their lab. So within a cold room, they thicken the ice in cooling boxes using different techniques, one small layer, multiple small layer, and then they monitor the melting of it. And the results of this laboratory research were really encouraging and positive enough for us to want to go to the next phase, organize for the first time a field test in the Arctic region itself. But before going there, we wanted to know much better what our possible impact on the Arctic ecology could be. So we asked an external ecology agency to create an environmental risk analysis for us. And this way we would better know what risks to encounter and how to mitigate them. And to give you an example, if we would use too much artificial light in winter, then that could trigger the zooplankton living at the bottom of the ocean to migrate upwards because they think, hey, it's already autumn, there's light, let's go and feed, and then they swim up and then there's nothing because that's our artificial light. These things we need to prevent from happening, of course. Also, my colleague Vonger, he traveled to the Canadian Arctic in January, which is not the site of our first field test, but the site for future operations when we would scale up. And we went there because we think it's crucial to engage the local indigenous communities as early on as possible and foster collaboration. We need to better understand their concerns and their needs. And yeah, one of the needs they have is that they still need to cross the ice in summer to be able to hunt for caribou on the mainland. So that could be a potential benefit. At the same time, I followed a set of intense safety courses organized by UNIS, University Center of Svalbard. It can best be described as 100 ways to die in the Arctic, I would say, and then fortunately also learning a little bit how not to die. And this is behind me, the sea ice safety training. It was my first visit in January to the Arctic and they immediately made me swim, so it was useful. And in the end, we thought we were well prepared then for our first field test. And this field test we organized at Svalbard in a place called Fallunen, which can best be described as the Arctic equivalent of a tropical laguna, so just much colder. We did this together with UNIS again and Delft University of Technology. We didn't stay at the field test location overnight. We stayed at the other side of the fjord in an old mining location where some huts remained. And this is how our daily commute looked like. So a bit different than back at the office. No traffic jams and a much nicer scenery. Then this is footage of the field test location itself. And you can see two small lakes on the ice. So this is where we're pumping water on the ice. You can even see one of our pumps working there. On the background, the dark structure, that's our sled, which provides some shelter, our base station, you could say. And in the middle of this pond, you see this orange thing, and that's the site of our measurement devices. So we installed so-called thermistor chains into the ice to measure the temperature profile of the ice, through which we could calculate the thickness of it and the thickness of the snow layer on top. And we also installed net radiation meters, and they measure incoming and outgoing radiation, through which we could calculate the albedo, the level of reflectiveness of the ice. Now, I was quite naive, and I always thought that science would be just a lot of thinking. But because we had to take salinity measurements, temperature measurements, and density measurements of the ice, also after we thickened it, we had to drill almost 100 ice cores. So field tests can be really hard work. And in hindsight, my respect to all the scientists on such field tests out there. But luckily for me, these measurement devices, they had remote connections, satellite connections, so we could observe the melting of the ice through the convenience of our warm offices. We also had a time-lapse camera installed with this remote connection, so we could visually monitor what was happening. And this is then a picture taken by this time-lapse camera during the melting season. And the good thing about it, the nice thing is that you can clearly see two of our thickened sites, sites B and C, standing out whiter and brighter than the rest of the ice surface. And we could also see this via satellite. On the left side, you see a satellite image of the time that we're still operating on the ice. And there you see the dark spots, and those are the areas that were thickening. But because it was still water at the time, it's darker, it absorbs more energy. But then during the melting season, you can see these three sides. In the end, we thickened three sides, standing out again whiter and brighter than the rest of the ice surface. So that was a positive thing to see. We also had some friends checking in on us sometimes. And just a couple of days ago, we released the field test results. So you can download them from our website, arcticreflections.earth. For now, I will just explain the highlights to you. The first one is thickening the ice with these temperatures. That really works. That's really no problem. Second, that's an important one. The melting of the thickened ice follows the same pattern as the melting of the non-thickened ice. So they both melt linear. And this is important because this indicates that the thickened ice can survive longer. It could also have been that the ice that we had thickened would collapse earlier because the salinity would be higher or any other reason. That wasn't the case, so that's really positive. And then the most positive thing was that for the first time we were able to validate via these net radiation meters that the thickened ice actually reflected more energy than the non-thickened ice. And we could also visually confirm this with pictures like the ones I showed you from the satellite and from the time-lapse camera. Now, another thing I learned about science, doing things once, that doesn't count. You always have to validate things multiple times because it can be just luck because that we had these results. So we're organizing a next field test, this time in the Canadian Arctic. And this is a location that makes a lot of sense because here is where the summer boundary of the sea ice is. And if we thicken the ice there, we can make use of natural ice drifts, the Beaufort Gyre, which can bring the thickened ice all over the Arctic region. So then we can use forces of nature. This time, we'll for the first time make use of amphibious vehicles to move our pumps over the ice, and we will use slightly larger pumps specifically designed for Arctic ice thickening. Then this is the last picture I'm going to present to you today. It shows a happy but exhausted field test team at the end of our Svalbard campaign. So Alexis Shestov and Tim Hammer were crucial in organizing this trip. And then we had Hajo Hendriksen, Laura van Dijken from IPMA and myself. But it is at this point that I want to acknowledge the concerns that some of you here in the room might have. Is it really necessary to intervene in such a pristine environment as the Arctic region? And is it arrogant to think that we as humans can save the Arctic ice sheet? Or shouldn't we just remain focusing on the most important goal of it all, reducing our carbon emissions? But here's the harsh reality. If we don't intervene, the summer Arctic sea ice is almost certainly going to disappear within our lifetimes. Just reducing carbon emissions alone is not enough anymore. And to understand, we need to treat carefully. Everything we do should be rooted in science. And we should be very, very carefully monitor for any unintended consequences. But I think here is where collaboration and open-mindedness come in. We should work together to find solutions that are as thoughtful as they are effective. We should bring together the best minds in science, in engineering, and in environmental conservation. Because what's at stake here is not just the Arctic. So let us stay far away from polarizing. And let's start polarizing. Thank you.
Thank you, Tom.
You're done.
Thank you. Wonderful presentation and very interesting perspective on refrosting the North Pole. It sounds very simple, taking water, refrosting it again. but I suppose it's not that simple to put it in action.
Exactly. So yeah, we're Dutch. We like to pump, but this is at a scale that's of course a bit larger than we're used to. Funding is a challenge, as is with all these sustainable initiatives, but also technology-wise. So the technology is proven already. So in the Canadian Arctic, people use pumps to create ice roads, and we kind of use that kind of model of pump a little bit bigger to thicken the ice in the Arctic. But it remains a challenge. It's 2 times the Netherlands.
You mentioned the funding, which is absolutely necessary. Who should fund this kind of refrosting, this kind of action?
Yeah, at first instance, we're really looking at the voluntary carbon market. So we thought what we're doing is kind of the ocean equivalent of reforestation. We're restoring the Arctic ice sheet. So we're thinking about issuing ice credits or ice preservation units. But the more I have been in talks with different companies, and the more I started thinking about that this money should firstly come from government, and only later from companies. So at the moment, we are depending on philanthropic money, also some really daring impact VCs, but they're really daring, so that they are satisfied with business case that shows a return only after 10 years, so that's quite unique. But for the short term, I think philanthropic money and government funding is the way to go for us. And we'll see how the voluntary carbon market develops over the next years. And then we can see whether that's interesting for us or not.
And what about us as individuals? How can we give a helping hand?
Go to our website, go to our LinkedIn page, and please follow us. So that will help already a lot. So just spread the word. And as I always say, everybody here in the room, everybody should think for themselves what they can do best. For some people, I heard this morning, they should eat less beef. I'm also not a vegetarian. Some people should drive their car less, but do whatever you feel is good, and I think everything counts. And don't judge other people if they don't do enough, because that's also a thing that I think can work in the wrong direction. If we point too much fingers to other people from, hey, you're not doing, I'm doing more than you are, and then that will discourage people. We should do whatever we feel is right. We should not lose hope, because if you lose hope, then it would mean you give up, and we can't give up because it's way too important to give up. So stay positive, do whatever you can, and just live your life consciously.
Thank you so much, Tom.
Thank you.
Thank you. I will